This is ELTN 115, presentation 4.1, Eagle tutorial part 2. This is what I am calling the Apocalypse Edition. Hopefully that was, well, that's supposed to be a GIF, but I think you get the idea. Okay, so today we're going to be looking at how to search for parts in the library, understanding packages and pinouts. And we're going to look at some more of the tools on the toolbar for the schematic, and we're going to complete a second schematic. Okay, so I'm going to launch Eagle. I've launched Eagle here. And by the way, I apologize for all the difficulties with downloading the full education version. They've made it kind of complicated, but right now, if you don't have that, it's okay, but ultimately we'll need to use it. And if you look on the top here, it'll be the education version. Your version might be a little bit newer, but it should say education on there if it's the full version. But if not, don't worry about it for now. So I'm going to go to a new project here, and I'm going to name it, we'll say Unit 4 555 circuit. And we will add a new schematic here. If you right click, you can click New Schematic, and we have a new schematic. By the way, the first time you add a part here, it usually takes a little bit of time for it to load the libraries. That was quicker than usual. But just like usual, we're going to add a frame to start with. So again, I clicked on Add Part, Frame, and it's going to be a small schematic. The ones that I typically use are either letter L or DIN A3L. Letter is a little bit smaller, so that'll work for now. And I'm going to place that on the schematic by left-clicking, and then hit Stop. And then I'm going to zoom to fit to see the whole image here. And we'll put a title here, like before. We'll call this the 555 circuit. And I'm going to change the text color here to symbols and the size to 0.15, which is a little bit larger. And then place that text on the bottom. Okay, so in this case, the schematic that we're looking at is a 555 timer circuit. Let me pull that up. And it looks like this on the top left there. So this is a schematic that we're going to be working on today. You'll notice some of the parts look a little bit funky. I'll talk about that in a second. But one thing that's important is that, so this device we're using is the 555 timer. It's an old part, but it's used in lots of projects. And on the bottom, so that's a physical package, what it looks like in the DIP package, the regular non-surface mount package. And then the bottom here shows the pinout. So it shows the pin numbers of the device. And it follows the standard convention of kind of going from 1 in the top left corner. The dot indicates pin 1 here and here. And it kind of goes in a circle here. Now, if you take a look at the schematic, however, the pin locations are completely different. And people kind of get frustrated by this. They don't understand why isn't it laid out the way that it is in the package. Well, the reason for that is typically when we draw schematics, we want to have the inputs shown on the left side here, outputs on the right, and typically the supply or the power voltage is on the top and the ground or the 0 volt is shown on the bottom. And that's just a standard convention for schematics. The flow typically goes from left to right as you're going from the inputs to the outputs on the schematic. And the power, it's kind of kept like bars on the top and the bottom for the power supplier power source. So that's a typical convention, and we usually follow that. But just that's kind of a gotcha. Sometimes people think that it's going to follow the exact pinout of the device, and that's not the case here. So it's always going to look a little bit different typically. Okay, so we also notice some of these schematic symbols look a little strange. And that is because these are probably more typical European symbols, where they use rectangles for the resistors instead of the kind of the crisscross symbol that we're used to. But that becomes part of what you need to do when you're looking at these circuits, is be able to identify what's what. And we can see here, because these values are in ohms, and for example down here, this capacitor symbol, it says 10 microfarads and has a positive symbol. That's kind of the way we'd identify it as a capacitor. The LEDs are pretty typical, although the arrows are kind of going in kind of a strange direction. Okay, so let's start on our schematic, and I'm going to go ahead and click Add Part here, and I want to do a search for this 555 timer IC. Now, if I just put 555 down here in the search window and hit Enter, it comes up with nothing. By the way, you can always clear the search by clicking on this X here, and that'll bring back all the parts that we usually see. So because for integrated circuits, there are lots of prefixes and suffixes that are used. We're going to use a wildcard, an asterisk, and then the 555. And now if we hit Enter, you'll see that there are some different options here. There's the ICM version from a company called Maxim. The one that we're going to be using is the NE555 from ST Microelectronics. And you'll notice that a couple of the pins are a little bit different than we saw in the schematic, but that's going to be okay. We'll work around that. Okay, so I'm going to place that part, and because it's the primary part that we're working with, I'm going to put it in the center of the schematic to start with. Okay, now again, you have to hit stop after you placed a part, or it'll keep placing more of them if you're not careful. So the next thing I'm going to do is add the power wires on here, and I'll zoom in a little bit so we can see our part. 8 and 4 are both connected to the positive supply, and 1 is connected to ground. So this doesn't exactly follow the schematic, because usually you'd see the VCC or the positive terminal on the top and the ground on the bottom, but that's okay. So we're going to go here and clear our search and go down to supply. In this case, we're in the supply 2 library. And even though the schematic said it runs on 3 volts, we're going to use 9 volts. That's more common voltage for circuits that we use for a project like this. So I'm going to click OK, and I'm going to add that symbol above. And I'm going to hit Escape, and it'll take me back to the library. The Escape key is kind of a handy way to go back to the previous library. And then I'm going to go and pick up a digital ground and add that down here. Okay, and hit stop. Now, I could probably move these over. It'll probably line up a little bit better, so I'm going to do that. I'm going to use the move command here, this little 4-way arrow. Click on that symbol and move it over, and click on the digital ground and move it over here. And then we're going to make our connections using the net command. Again, do not use the wire command, or the line command. That's a mistake. We want to use nets. And we'll learn why that's so important later on. So I'm going to connect between VCC and 9 volts. And you'll notice as soon as I'm done making that connection, it breaks the connection, which means we've got a good connection. And I'm going to click there. Now, when I run the ERC later, you'll see that there's some issues here because the name VCC does not match 9 volts. And ground does not match digital ground. We could have changed that to ground. We'll get into that a little later. Next thing we're going to do is we're going to add the resistors, and I'm going to kind of do this all at the same time, and because I've got the schematic in front of me, I can just figure out roughly where those are going to go. Now, if you remember the schematic, this is the RCL, resistors, inductor, or capacitors, inductors library, and I'm going to go to RUS and RUS 0204/7, and I'm going to click that. I'm going to right-click because all of these components are vertical, and that'll keep them in the same orientation. So I'm going to click, let's see, there, 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 and there. And I like to add these kind of all at the same time instead of adding them one at a time. Okay, so R1 and R2, I'm going to put the values on there. And this is going to be based on something that's a little more typical of the circuits that you see here for the values for a kind of a slow flash rate. But I'm going to change the value here of the R1 to 1K and R2 to 1K. I think you can also double click on the symbol package too. And then I'm going to use a net to make the connections between them here and here. And then for 3, I'm going to draw a net out here. Actually, I'm not going to do that. That's not the best approach. Let me go ahead and put the other values here real quick. We will change the value of R3 to a 1K ohm resistor also, and R4 to a 1K. So they're all the same value. Next thing we'll do is add the capacitor. Now this capacitor is different than the one we used in the previous lab. This capacitor is a polarized capacitor, so it's called electrolytic. And so we're going to use this CPOL-US, and again, this is in the whole RCL library. So I'm going to click on that and you go, oh man, look at all these parts. How on earth do I figure out what I use? Well, I've given you a guide sheet, and again, I'd recommend printing it out or having that in some place where you can get to it easily. That'll make it a lot easier to find these parts. So I'm going to go to CPOL-US, and I don't even remember exactly where this is at. Here we go. And I'm going to pick a package here like 2.5-6. And what that represents, the 2.5 represents it's 2.5 millimeters or 2.54 millimeters between the leads, which is 0.1 inch. And the diameter of the capacitor is 6 millimeters. That's the actual diameter. You can kind of get a rough idea of the size looking here. Okay. Now, I wouldn't expect you to know that. There's so many packages here, but this is a common package. Okay. So I'm going to click on that, and I'm going to add that part over here. And I'm going to hit stop, and then we've got 2 LEDs to add. And if you look at your kind of help sheet, if you go to the LED library, this is kind of a little weird. We're going to go to the LED library, and once again go to the LED library, and we're going to pick the 2 common sizes that we use for through-hole LEDs, or 3 millimeter or 5 millimeter. We're going to go with the larger ones, the 5 millimeter. You can see the 3 millimeter are a little bit smaller. It doesn't show an image of it. Okay. And we're going to put one there, and we're going to put one there. And now that concludes all the different components we need, so now we just need to connect everything. So pin 7 connects between these 2 resistors here. I'm going to click it, and once I click it, you'll see that bubble show up. That's called a, what is that called? A junction. And usually that'll show up when you make that connection. Now, the schematic here does look a little bit different on the original schematic I had, but the top of this resistor is going to come over, and it's going to connect to, connect to pin 8. Now, this is kind of I'm a little picky about this, and I'll show you what's the reason why. If you make a net connection right at the pin, it makes it hard to move it around if you want to move it later. So what I'm going to do is move this, there we go. I'm going to move that symbol a little higher, redraw the net so that it makes a connection here. And the reason for that is if I wanted to, for example, move that part around, it makes it a little easier to move it. Okay, 4 is also connected to the supply voltage. So I'm going to click back on net and make a connection there. Let's see what else we've got here. 2 and 6 are connected. Now, we've got a crossing here, but that's okay. That does not mean it's electrically connected. It doesn't mean there's a short, so there's no problem there. That's not an issue. The resistor is connected to pin 6 there, and it's also connected to the capacitor, and it's also connected to, pin 2, like that. Now, you sometimes get this message if you've got nets with different names that are connected. That's okay, it's not a problem. Okay, I'm going to zoom out a little bit so we can see what's going on here. So this is our schematic so far. I'm going to move these resistors a little bit here and the LEDs, if I can grab them. That looks pretty good. So I'm going to go back to net here and make a connection to this LED, this resistor and LED, and here also. Pin 5 isn't really used in these schematics. It doesn't really serve any purpose. Sometimes you'll see a capacitor connected. We are not going to do that. Okay. Now, I want to add a ground here to this capacitor pin. And I could run a wire all the way over here, but it kind of gets messy. So what I'm going to do is something different here. I'm going to use a copy command, which is over here on the left, just a couple down from move. I'm going to click copy on that digital ground symbol and move it over here. And I'm going to draw a net that's going to connect those two. Now what's cool about this is that if I click on this eyeball symbol and click show, if I click on that ground, it's a little hard to see, but this net lights up and this net lights up. So any net that's connected to the same type of component or the same named component will mean that it's electrically connected. And that really is a good way to kind of keep your schematics clean. I'm going to do the same thing here for the supply voltage. I'm going to copy this 9-volt symbol over here. If you actually place it on the resistor, it'll do the same thing as running a net to it. Okay, so this is our schematic is pretty much done here. Let me look it over. So far, everything looks correct. But we also have the battery. Now, people will try to add a battery symbol to the schematic, but in reality, oops, oh, did you catch that? I left something off here. We're going to copy a ground symbol from here over to here. That was my bad. We would have seen that when we ran the ERC. Okay, where was I? Oh, the battery. The battery, even if it's in the schematic, it's not necessarily on the circuit board. Let me show you why. For the most part, batteries and some of their components like switches and variable resistors, for example, LEDs sometimes, are not on the circuit board itself. If you ever opened up any device that's battery powered, usually the battery, unless it's like a little coin battery on a remote or something, maybe like a key fob, the connector for the battery is actually on the board, but usually they aren't. So what we usually do is the battery is not shown on the schematic. Even though it's part of the circuit, it's separate from the printed circuit board. This is very important. So the question is, how do we connect the battery? Well, we can use these devices called terminal blocks that can plug into the circuit board, and then these wires might be connected to a battery. We can use a barrel jack, which you think of as like, for example, for a 9-volt adapter or a 5-volt adapter that can plug in. Or we can use this what is called a JST style connector. That's a locking connector. So this part on the bottom would be soldered to the circuit board, but the connector would allow us to connect it to the battery. So we don't show the battery on the schematic. So in this case, what I'm going to do is add a terminal block, and we'll look at some other terminal blocks later on. I'm going to go to a library, and this is on your cheat sheet, ConPhoenix 2.54, and that shows you what the terminal block pads look like and the schematic symbol. And that's the way we actually wire in the battery to the circuit. So what I'm going to do over here is add that those symbols, and then I'm going to copy the 9-volt symbol, and I'm going to copy the ground symbol. And by the way, this is what I left off of the previous schematic, why you might have been getting an error. And I'm going to connect those two terminals together. And so what that means is that the battery is external to the circuit board. But just like before, because we've got that connected to the 9-volt circuit, all the electrical connections are the same, even though you don't see a trace connecting there or the ground. All those are connected together. Okay, so now we're done with our schematic. Let's run the ERC and see if there are any mistakes. And we get a couple here. It says unconnected input IC1CON. Well, that's just too bad. We're not going to connect it. But Eagle is saying that's a problem usually, so it's something you want to kind of watch out for. The other one, it says that IC1 ground is connected to D ground, and that power IC1V++ is connected to 9 volts. Now, that's really not a problem. We've just changed the name. So what we'll probably do is clear those errors. But let me just show you really quick here. If I change this part, let me see if I can actually do this on here. If I change the package, nope, can't. I'm going to delete that D ground, and I'm going to instead add, you don't have to do this on your schematic, but just so you can see what's going on. I'm going to add just ground. That's the name of it, and I'm going to connect it there. Whoops, and I got to do that for the other ones too. Let's add that part again. So now what I'm doing is naming it the same name the part name is the same name as the ground name there for the device. And when I run the ERC, you'll notice that that error doesn't show up anymore. So it's really not critical, but just something, if you see that pop up, that's why. So here we got VCC is connected to 9 volts. If you click on the message, it'll say what the problem is. Whoops, left off the value of the capacitor. So we'll just put, for example, 10 microfarads there. And the ERC also does not dynamically change. If you make a change, you have to run it again to see. It says part X1 has no value, don't care about that. The LEDs don't have values, don't care about that. And the frame doesn't have a value. So what I'm going to do, even though it says there's an error here, I'm going to approve all of these errors. And then what that does is that if you want to go back and look at it and see what the errors are, you can check and see. Okay. So that's our complete schematic. In this week, we'll also be building the circuit on a breadboard, which is a whole nother kind of challenge. But I'd like you to build this schematic. And if you have questions, let me know. I just wanted to go over real quickly before we're done here. I know this is kind of getting long. You can always watch this at 1.5 speed, right? But there's some other things I did want to show you on the toolbar here. The info button, if you click on that and click on a part, it gives you a whole bunch of information on there. So that's what that info button is. Group we talked about before. That's, for example, if I wanted to move this whole kind of section of the schematic over, I can do that and click on move and right click, move group, and it allows me to move that as a group. Mirror allows us to flip schematic symbols. That is not so useful on the schematic, but in the board we'll see why that's important. Delete, I think we talked about before. I just ran through it when I deleted those packages. And I think the other ones we'll hold off for the next session. There's a lot that we'll get into when we get into the board design. Okay, so see if you can get through that schematic. If you have problems, hopefully you won't, but if you do, let me know. And then this will be your schematic project for this week, and then you'll be breadboarding the circuit if I can get back onto campus and get the parts.